Introduction. Journey through Earth's deep time history. Earth has a story that spans more than 4.5 billion years. It's a tale written in rocks, ice, and fossils that tells us about incredible changes, mysteries, and transformations. This story reveals the powerful forces that shaped our continents and oceans, and shows us how life miraculously began and evolved. As we look back through time, we see periods of violence and peace, extinction and creation, all leading up to the arrival of humans and our current time period. Understanding deep time. The term deep time helps us understand just how incredibly long Earth's history really is. When we think about deep time, human lifespans seem tiny in comparison. We're talking about time periods measured not in years or decades, but in millions and billions of years. It's a time span so vast that it's almost impossible for our minds to fully grasp. Earth's history is divided into 4 major time periods called eons. The Hadean Eon marks Earth's very beginning over 4.5 billion years ago, when our planet was a fiery, molten ball. The Archean Eon saw the first solid crust and oceans form, along with the first simple life forms. The Proterozoic Eon brought oxygen to our atmosphere and more complex organisms. Finally, the Phanerozoic Eon, which we're still in today, is famous for having abundant visible life, including dinosaurs, mammals, and eventually humans. Each chapter of this ancient story reveals secrets buried deep in Earth's rocks and fossils. These geological records let us witness mass extinctions, planetary changes, and the evolution of life forms that would eventually lead to us. The fiery beginning, Hadean Eon. The Hadean Eon, lasting from 4.5 to 4.0 billion years ago, was Earth's most violent period. Our planet was born from chaos, with asteroids and other space rocks constantly crashing into it, creating a hot, molten sphere. There was no atmosphere as we know it, no oceans, just an inferno of heat and destruction. As Earth slowly began to cool down, the heavier materials sank toward the center, creating the planet's basic structure with a core, mantle, and crust. The constant bombardment of meteorites likely brought water to our planet, which would later become our first oceans. Some of the oldest rocks on Earth, found in places like Western Australia and Greenland, date back about 4 billion years. These ancient rocks are like time capsules from this fiery period of Earth's infancy. By the end of the Hadean Eon, Earth had become more habitable. It had a solid crust and the beginnings of an atmosphere, setting the stage for life to eventually emerge. The birth of life, Archean Eon. The Archean Eon, from 4.0 to 2.5 billion years ago, was when Earth's first stable crust formed and life began. During this time, oceans formed as the planet's surface continued to cool. The first life forms were simple, single-celled organisms called prokaryotes. These tiny creatures were nothing like the complex life we see today, but they were the foundation for everything that would come later. We know about these early life forms from microfossils and special rock structures called stromatolites. These layered structures were built by communities of microbes, and some are over 3.5 billion years old. The atmosphere during the Archean was very different from today's air. It was mostly made up of methane, ammonia, and other gases with almost no oxygen. This period shows us Earth's amazing ability to adapt and change. These simple life forms laid the groundwork for all the biological complexity that would follow. The Oxygen Revolution, Proterozoic Eon. The Proterozoic Eon, lasting from 2.5 billion to 541 million years ago, witnessed one of the most important events in Earth's history, the Great Oxidation Event. During this time, tiny organisms called cyanobacteria evolved the amazing ability to photosynthesize, which means they could use sunlight to make food and, as a byproduct, release oxygen into the atmosphere. This might sound like a good thing, but rising oxygen levels actually caused major problems at first. Oxygen was toxic to many early organisms, leading to mass extinctions. However, this catastrophe also opened the door for new types of life that could use oxygen to survive and thrive. The first eukaryotes appeared during this time. These were much more complex cells with nuclei, and they paved the way for multicellular organisms. Late in this eon, Earth may have experienced snowball Earth periods when the entire planet was covered in ice for millions of years. As the Proterozoic Eon ended, life forms had become increasingly complex, setting the stage for an explosion of biodiversity in the next chapter. Life explodes, the Phanerozoic Eon. The Phanerozoic Eon began 541 million years ago and continues today. This eon is famous for abundant, visible life and includes three major eras: the Paleozoic, Mesozoic, and Cenozoic. The Paleozoic era began with the Cambrian explosion, a period when most major animal groups appeared relatively quickly. The seas were filled with creatures like trilobites and brachiopods. Later, plants moved onto land, followed by insects and the first amphibians. The Carboniferous period created vast swampy forests that would eventually become our coal deposits. This era ended with the Permian extinction, the most severe extinction in Earth's history, when 90% of marine species disappeared. The Mesozoic era, often called the Age of Reptiles, was dominated by dinosaurs and giant marine reptiles. Early mammals and birds also appeared during this time, and flowering plants transformed landscapes. This era ended abruptly with the Cretaceous-Paleogene extinction event, likely caused by an asteroid impact that led to the downfall of the dinosaurs. The Cenozoic era, which we're in now, is known as the rise of mammals and humans. After the dinosaurs disappeared, mammals quickly evolved and diversified to fill empty ecological niches. The climate cooled, and ice ages sculpted much of the northern hemisphere. Primates emerged and eventually gave rise to humans. Homo sapiens appeared roughly 300,000 years ago, developing tools, culture, and society. Today, humans have such a big impact on the planet that many scientists believe we've started a new epoch called the Anthropocene, learning from ancient catastrophes throughout Earth's history. Mass extinctions have repeatedly reshaped life's path. Each catastrophe was followed by adaptive radiations, which are bursts of evolutionary creativity that result in new species and ecological opportunities. These events teach us that while extinctions can be devastating, they also create opportunities for new forms of life to evolve and flourish. Reading Earth's story. Geologists unlock Earth's secrets by studying rocks and fossils. Ancient rocks and crystals called zircons reveal information about our planet's origins and major transformations. Fossil records chronicle the rise and fall of entire ecosystems. The magnetic orientation of minerals, ice cores, and sediment layers tell us about shifting climates and how continents have moved over time. Our place in deep time. Even though humans have only existed for a tiny fraction of Earth's history, our impact on the planet rivals that of ancient catastrophic events. We've changed the atmosphere's composition, reshaped landscapes, and caused extinctions. Understanding deep time gives us perspective on our responsibilities as stewards of Earth's future, reminding us that we're part of an ongoing story that's much bigger than ourselves. Thank you for watching. Follow my channel for in-depth explanation of each eon and ancient catastrophes. Like, subscribe, and share.